Hello, class. We're about to start section 312. As you all see, this is the week of the 22nd through the 25th, and we're supposed to cover sections 3.12, 4.1, and 4.2. So today I'm going to go over 3.12. I may go over 4.1, but I'll see as the class progress. But by the end of the week, we'll be done with up to and including 4.2. Okay, so we need to first turn to page 373, and we're going to go from 373 to 376, and we're going to do problems 1 through 11 odd. Now, I'm not going to do every single problem because there are some problems I want you to try on your own, but I will do at least 4 of these problems for you. So, with that being said, we come here. This is page 373. This is the bottom of it. Let me make sure. Yeah, this is the bottom of page 373. And we're doing section 3.12. And we're going to do problem number 1. Now, problem number 1 states the amount of monetary damage caused by reported cybercrime to the Internet Crime Complaint Center, IC3, for various years from 2001 to 2016 in millions of US dollars is given in the following table. Now, it says use your graphing calculator to determine the exponential regression model D equals A times B to the T, where T represents the number of years since 2000. Round the value of A to 1 decimal place and B to 3 decimal places. Okay. So first of all, let's set up some parameters here. Okay, for 1A, again, we're told we're going to use this formula. D is equal to A times B to the T power. Okay, now this formula is really this formula here, y equals AB to the x power, which we've covered before. The only two values that really changed was y became D and x became T. All right, now we're also told that everything is since 2000. So with that being the case, when we look at the years that's provided to us, our years, and I'm just going to write the years down here. Instead of writing 2001, 2004, and so on, we'll go since 2000. So it'll be 1, 4, 7, 9, 12, 14, and then also 16. These would be the years. Now, of course, I'm not just going to write everything out on this paper here, but I'm just giving you a little basis before we go to the calculator. So let's go to the Desmos calculator, which is here. Now I'm going to move it over a little bit so we'll be able to see everything. So we had our plus sign, we have our table, and we've already established our years to be our x, so it'll be 1, 4, 7, 9, 12, 14, and then 16. Now our Y value would be the cybercrime damage in dollars. So it'd be 17.1, and this is millions of dollars. I mean 17.8, be 68.1, 239.1, 559.7, 581.44, 800.49, and 1,330. Okay, now our next step, they want us to put it in the form of D equals A times B to the T, which as I showed you all here, is the same as saying Y is equal to A times B to the X. So we're going to type this in here. So we have Y1, we'll hit our keyboard, hit our ABC, we'll get our tilde, and that'll be A, B, and then we're going to take this to the x1 power. I have to do the exponent and then x1. Okay, now, whenever you're doing this, this is an exponential regression. You must click on log mode before you start writing out any equation. Now, if we look here, it tells us to round the value of a to 1 decimal place. So we know that'll give us 23.3 for a. And then they tell us to round b to 3 decimal places. B would be 1.312. So if we wrote this out, we would have d is equal to, a would be 23.3 times b would be 1.312, and then we would take that to the t. So if we wrote this how we normally would see it, it would be 23.3, and then the b would be in the parentheses, and then that would be taken to the t power. So this right here would be your final answer. Now that took care of b. Now we want to move on to the next page. I'm sorry, that took care of A, not B. Okay, B, according to the model, what was the monetary damage caused by cybercrime in 2013? Now, we want to use this model here, and they say in 2013, so since 2000, that'll be 13. That will represent T. So we would take, this would be B, we would take D is equal to 23.3 times 1.312, and then we would take that to the 13th power. So D is equal to, we'll put this in our calculator. We have 23.3, parenthesis, 1.312, close the parenthesis, and then we would take that to the 13th power. And that would give us 795.24. And we know that'll be million. So I do not believe they told us to round to a particular place, but we could check that out. Let's see. No, it doesn't tell us to round to any particular place. Okay, C. According to the model, when will the cybercrime damage reach $2 billion for the first time? Now remember, everything is according to millions, but now we're being asked to predict billions. So basically for C, we're going to take this same equation, but this time we're going to try and solve for T, and we're given D. D is that 2 billion. Now remember, it takes 1,000 million to equal 1 billion. So to equal 2 billion, that'll be 2,000 is equal to 23.3 times 1.312 to the T. So now we will go through and solve this. Divide each side by 23.3. So you have 2,000 divided by 23.3 is equal to 1.312 to the T power. Now, with this being said, the section that we went over logarithms on, this will be a help as far as dealing with the logarithms. Because what we could do is this here, we want to get T by itself. So we could take the log, and we could use this as the base here, this 1.312 as the base of 2,000 over 23.3. We could do that on both sides of the equal sign. Now let me explain why we did that. By having this base and this value the same, remember these will simplify out and then leave that T by itself. Now, we could put this in our calculator and solve this to get what our T is equal to. And remember, that's years since 2000. So let's get our calculator. So we would take, we got to go here to the table and functions. We'll go to miscellaneous. Then we will go to log with that base there. And our base is 1.312. And then in parentheses, we add 2000 divided by 23.3. And that gives us 16. If we round to 2 decimal places, that'll be 16.40. So what would happen here is we would say in 2016, the amount will reach $2 billion. All right. Now that took care of problem number 1. Now we're going to roll on down here to problem number 5. I think that would be on the next page. All right, problem number 5. It says in exercises 4 through 9, solve each equation using the algebraic approach. Verify your answers graphically. All right, so we have number 5. We have 3 to the 2x power is equal to 8. Now, what we want to do is this here. We want to solve this equation using the algebraic approach. So we could use natural logs or we could use logs. It doesn't matter which one that we pick to use. Since we were using logs before, let's just go with the log. So if we do log on both sides, make the base 3. If we do log base 3, the 3 to the 2x equals log base 3 of 8. This would give us here 2x is equal to log base 3 of 8. Now we could divide each side by 2. And x is equal to log base 3 of 8 all over 2. Now we put this in our calculator. We go to functions, miscellaneous, log base. We know our base is 3. And then what's in the parenthesis is 8. And then we will do our division. And then that would be divided by 2. So our final answer, if we round to 2 decimal places, would be approximately 0.95. And that would be our final answer. Now, let's take a look here at problem number 9. We add e to the negative 0.3t is equal to 2. Okay, now, remember I told you we could use log or natural log. I would suggest that we use natural log because we have e as a base here. So if we did the natural log on both sides, remember the base of a natural log is assumed to be e. So the natural log and the e would simplify out and leave us negative 0.3t is equal to the natural log of 2. We could divide each side by a negative 0.3. And then t would be approximately, we got to go here, go back to functions. This time we'll do natural log, and then that'll be 2. We'll close our parenthesis, and then it'll be divided by a negative 0.3. So our final answer here would be approximately a negative 2.31. All right. I think you may need to see another example of that, so I'll do problem number 7 as well. Problem 7. We have e to the 0.05t is equal to 2. Now again, since we have a base of e here, it would be a better use for us to do the natural log. So we could do the natural log on both sides. Natural log e would simplify out and leave us 0.05t is equal to the natural log of 2. We divide each side by 0.05, and t would be approximately, we will go here, functions, miscellaneous, we'll do natural log of 2, close that parenthesis, divided by 0.05. We round the 2 decimal places, it'd be 13.86. All right. Now, we are asked to verify this graphically. So what I need to do, I need to go back up here and turn off this graph. So then we won't see the graph here. So we're supposed to verify this graphically from problem number, what's that, 5, 7, and 9. All right, so this is problem number 5. We click here. You click on this wheel here. And then what you could do, looks like it only has the note. Okay. All right. So I guess what we could do, let us see here. Okay, class, yes, you're not supposed to make a table with this because as you see, there's no variable showing here. But what we need to do is go back to the original problem. Let me pull it back up on the textbook as we want to prove this graphically. Okay, the original problem for number 5 is 3 to the 2x is equal to 8. Now to prove this graphically, what we would do, we would take both of these values and have y equal to both of these values separately. So y is equal to 3, and then we will go here to the 2x power, and that's one part of the graph, and then we have y is equal to 8. Now we have both parts. Now when we look here, what we're trying to find is their intersection point. Their intersection point is at 0.9468. Now we know we rounded to 2 decimal places. When we rounded to 2 decimal places, we got 0.95. So that actually works. All right, so now we're going to try, and let me turn off these graphs here. We're going to try problem number 9 next. Now with problem number 9, we had e to the negative 0.3t equal 2. We're going to make this t an x. So we'll do y is equal to e, and we'll take that to the power of a negative 0.3x. Now that took care of the first part. Now we go to the second part. We have y is equal to 2. Now we go to their intersection point, which is here, which is a negative 2.31, comma 2. So we go back up here when we solved this problem, it was a negative 2.31. Now we're going to go back and do problem number 7. Same exact method. Let me just turn these graphs off. It's the same exact method. So we'll take y is equal to e. Then we would take it to the power of 0.05. And we'll put our x. And then we will have y equals 2. Now the point where they intersect at is here. So we go back up. We notice here 13.863, and our answer we got here was 13.86. So we also proved this graphically. Okay, class, we're going to move on to section 4.1, which starts on page 399. Now, the problems we're supposed to do here, I believe, is problems 1 through 11. No, 1 through 13I. But what I'm going to do here, I'm going to do about 3 or 4 problems here to get you started, and then you should be able to do section 4.1, the rest of 4.1. Okay, we're going to start off first with problem number 1. Now, with problem number 1, we would need to use our graphing calculator because, well, technically we don't. It says complete the following table of f of x equals x squared. So all we need to do is just square each of these values. So in order to complete that table, I'll draw a quick little table here. And this is just 1a. So we have x, and then we have f of x is equal to x squared. So -3, -2, -1, 0, 1, 2, and 3. So if we square each one of these, this will give us 9, 4, 1, 0, 1, 4, and 9. So that would take care of 1a. Now we move on here to 1b. Now 1b says, use the results of part A to sketch a graph of y equals x squared. Verify using a graphing calculator. All right, so let's get our calculator. And we could type in y is equal to x squared. Now just to take a quick little look here, this is a representation of the graph y equals x squared. Now it says, what is the coefficient of x squared? Now we know with a coefficient, that's the value in front of the variable. It says, what is the coefficient of x squared? When you don't see a value in front of the variable, it's assumed to be 1. So the coefficient of the x squared is 1. Now we come to D. It says, from the graph, determine the domain and range of the function. All right, so let's pull this graph back up. Okay, when you look here, this graph basically goes on forever, but it's going on forever in the x value. So D, the domain, which we know domain is the x values, the domain is all real numbers. Okay, now the range is the y values. If you notice here with the range, with the y values, it stops at 0. So 0 is the lowest value, but then it goes on forever. So then we could say the range is all numbers greater than or equal to 0. Again, the range is all numbers that are greater than or equal to 0. Okay, now we go here to E. It says create a table. Wait a minute, let me pull this up. Looks like my camera is frozen, but I'll take care of that really quick. All right. All right. Now for E, it says create a table similar to the one in exercise 1A to show the output for g of x equals negative x squared. Now, if we look here, we can do the table again. Now we can put this in our graphing calculator, but let's just put this in a table since we're dealing with small numbers here. So we have x and g of x is equal to negative x squared. So we would basically have the same numbers, negative 3, negative 2, negative 1, 0, 1, 2, and 3. So we know that when we put in negative 3 and x squared, that gave us positive 9. But we also have a negative on the outside. So basically all this is going to do is just change all the signs of these here except for the 0. So this would be negative 9, negative 4, negative 1, 0, negative 1, negative 4, and negative 9. Now for F, it says sketch the graph of g of x equals negative x squared on the same coordinate axis in part A. Verify using a graphing calculator. All right, so we're going to do our graphing calculator. So we want to graph y is equal to negative x squared. Now, if you notice, it's basically the mirror opposite of this value here. They look the same except for one is upside down. Okay, now we go here. It says, what is the coefficient of the term negative x squared? So again, the coefficient is the value in front of the variable. When there's no number shown, it's assumed to be 1. But since we have a negative sign there, the coefficient would be negative 1. Now we come here to H. How can the graph of y equals negative x squared be obtained from the graph of y equals x squared? They are mirror images of each other. So y equals negative x squared is a mirror image of the y equals x squared over the x-axis. All right. Now we move on. Let's see, let me go here to problem number 5. Problem number 5, it says use your graphing calculator to graph the two functions. y1 equals 3x squared and y2 is equal to 3x squared plus 2x minus 2. Now for A, it says what is the vertical intercept of the graph of each function? And then B, compare the two graphs to determine the effect of the linear term 2x and the constant term negative 2 on the graph y1 is equal to 3x squared. Okay. So the first thing we want to do is graph this. So we go here to the graph, and then now I want to turn these graphs off. Okay, so we don't have to do the y1 and y2. We could just do y is equal to 3x squared. And then we could do y is equal to 3x squared plus 2x minus 2. Oh, this is, oh, okay. Yeah, I gotta zoom in a little bit here so we can see that these graphs are not the same. All right, now let's take a look here at A. It says, what is the vertical intercept of the graph of each function? Now, when it says vertical intercept, they're asking you for the y-intercept. So they're asking us for the y-intercept for that problem. So this would be A. And then we will write this down as y1 and y2 because that's what is listed in the book. So on y1, which would be the first graph here, which would be the red one. We see this red graph here. We want to find the y-intercept. And the y-intercept is when x is 0. And where x is 0, the ordered pair would be 0, 0. Okay, y sub 2. Now we have the y-intercept, and we want to go where x is 0, which would be this blue graph here. We go where x is 0, and we come down here. So then when x is 0, y is negative 2. These are going by negative 2s. So it'll be 0, negative 2. Okay, so now that's A. Now we go here to B. It says compare the two graphs to determine the effect of the linear term 2x and the constant term negative 2 on the graph of y1 equals 3x squared. Okay, so we see here that y equals 3x squared. We know that this is the red graph. But we notice here that this graph, the blue graph, it shifts to the left and it also goes down. So in general terms for B, we could say the 2x and the negative 2 make the graph shift to the left and down. Because we can see that. It makes it shift to the left and down. Okay, now what we want to do here, just to help this out a little bit for your notes, let's find out which one would make it shift to the left and which one would make it shift down. So let's just take this off here. If we do the plus 2x, you notice here with the plus 2x, this graph just shifts. So the graph shifts. But then when we add on the minus 2, it goes down. So the 2x made it shift to the left, and then the minus 2 made it go down too. So now we know what made it shift and which way. All right, next. Let's see, let's go to problem number 9. We have r of t is equal to 3t squared plus 10. It says A, determine whether the graph opens upward or downward, and B, the vertical intercept. Now, so 9A and then 9B. All right, now we could do this a couple ways. we could just basically put this in our Desmos calculator and see whether it's open upward or downward, and then we could determine the vertical intercept. So let's do that first, and then I will show you another way that we could do it as well. So I want to turn these off, and then I will have y is equal to 3x squared plus 3x, oh, I'm sorry, it's supposed to be plus 10. And I just changed that t to an x. So we got 3x squared plus 10. Okay, we see the graph that is opening upward. So we'll put upward. And then for b, we want the y-intercept. And you notice here the y-intercept is basically at 0, 10. Because when x is 0, y is 10. Even though it doesn't look that way here, but now it does. When x is 0, y is 10. Okay, so this is one way of doing it. We could put it on a graph, call it a day. But let's just say that for some reason we forget about the graph. We could go back here, I believe it's page 397. What was it, 396? It's one of these pages here. Oh, here it is. Okay. We have a definition here. It tells us if a is greater than 0, the parabola opens up. Now, this is the formula that tells the characteristics of a parabola. F of x is equal to ax squared plus bx plus c. This is the formula of a parabola, or the form for the parabola. Now, a is the value in front of your x squared. Now, it's saying here that if a is greater than 0, the parabola opens downward. Upward, I'm sorry. If a is greater than 0, the parabola opens upward. Now, if we go back, well, let's look here, and if a is less than 0, the parabola opens downward. So let's go back to where we were. I think we was on page, no, I think it was page 400. Okay, here we go. This is page 401. Now, if you look here, how this formula is set up. Now, this is the standard form. But if we look at this formula here, we have r of t. We know t represents x is equal to, this would be 3t squared. So this matches up here. And the plus 10 will go for c. We don't have a bx portion here. So we look here at the a value. Any value that's greater than 0 is a positive value. And since we see we have positive 3 here, that lets us know that it opens up upward. And then also with our constant c here, I didn't point that out, but I will point that out here. Whatever your value here is at the end, or the c, the constant value that doesn't have the variable when it's set up in standard form, this would be your y value for your ordered pair, for your y-intercept or vertical intercept. So just to get in one more problem, let's do problem number 7. We have g of t is equal to 1/2 t squared plus t. So we're basically doing the same directions we had before. So we look here at a. This is a positive number, so we know this is upward. Now b, it asks us to write down the y-intercept or vertical intercept. Now first of all, we know x is going to be 0. That's one of the requirements. So now we want to find the y value. Now the y value, remember I told you in the previous problem, is the constant number that does not have a variable. If you notice here, we do not show a number that does not have a variable here. So that number is assumed, and you don't have to write this. That number is assumed to be 0. So your vertical intercept here would be 0, 0. So now we're basically done with 401. There are some problems I did not cover that you're supposed to do on your own, and you could bring me those questions. You could send them to me or contact me via my email. And have a wonderful day.